Okay, here we go. On number 1, for mean, median, and mode range, we're trying to find x. So we're given these 4 numbers plus an unknown number that have a mean of 110, and we need to find out what that x number is. Well, we know that mean is equal to the sum of the data, in other words, just add it all up, divided by the number of data points. In other words, divided by how many, right? So let's take our mean, which is 110, and set it equal to the sum of the data divided by how many points. Well, if we sum the data, we're going to have 101 plus 103 plus 99 plus 122 plus some x that we don't know, all divided by 1, 2, 3, 4, 5 data points there. To solve for x, we've got to try to get x by itself here. We're going to multiply both sides by 5. 5 times 110 is 550 equals, if I add up all that data, 101, 103, 99, 122, I get 425, and then plus x. I want to get x by itself, so I subtract the 425 from both sides, and what I get is 125 is x. So for number 1, we've got the value 125. To check that, just take 101 plus 103 plus 99 plus 122 plus 125, add that all up, divide by 5, and make sure you get 110. Should work out just fine. For number 2, we are after the mean and the range. Remember, the mean is just the average, the same average that we just calculated here, sum of the data divided by the number of data points. And the range is just the smallest subtracted from the largest value, or the largest minus the smallest. If we add these up and divide by how many, we should get 21.5 for a mean. And if we find the largest value here at 40 and the smallest value at 11 and subtract, we should get a range of 29. There we go with numbers 1 and 2. Okay, number 3, our math teacher allows us to choose the most favorable measure of central tendency. Remember, central tendency is just mean, median, or mode to determine our grade. We have 6 test scores, 92, 89, 86, 76, 79, and 92. We want to know what our grade should be, or to the nearest whole number, and which measure of central tendency should we choose. And again, we should choose the one that gives us the highest grade. So we need to calculate a mean, a median, and a mode, and then pick the highest one and say which one the highest one is. Well, if you're lazy like me, you're going to do the easy stuff first. There's 2 92s, nothing else repeats itself, so 92 is the mode. We're done with that. The mean, if we just add them up and divide by 1, 2, 3, 4, 5, 6 things, I got 85 2/3. And the median, let's see, the median, we need to put these in order. So 76, 79, 86, 89, and 92 a couple of times. And then find the middle. Well, the middle is right between 86 and 89. So we need to find the average of 86 and 89. So add 86 and 89 together and divide by 2, and we get an average of 87.5. So the median would be 87.5. So what do we want our grade to be? Well, we want our grade to be 92%, and that 92% comes from the mode. So we would say, teacher, give us the A- using the mode. That's it for number 3. Number 4, we're going to solve some equations here in concept 2. We're trying to get this x by itself. I've got 1/3 times the x, and then I've got 4 added on, and that equals 9. Let's go ahead and subtract the 4 from both sides. That leaves me 1/3 of x equals 9 minus 4 is 5. 1/3 times x is kind of like x divided by 3. So if I want to undo that, I should multiply by 3. So I'm going to multiply 3 times both sides. These 3's reduce out, which is what I'm trying to get to happen there on the left, and x equals 15. Let's check that real quick in our head. 1/3 of 15 is 5, plus 4 is 9. That would check, so this answer has to be right, and it can't be wrong. That's number 4. Okay, still on concept 2 here with number 5. We're solving for d. I've got 12 equals the opposite, or negative d plus 18. I want to get rid of the 18, so I'm going to subtract 18 from both sides. That gives me negative 6 equals negative d. If I multiply both sides of that equation by negative 1, I'll get a positive 6 equals a positive d. That's what I want. Let's plug it in and see what we get. Negative 6 plus 18, that's 12, which equals 12, so that checks. This answer has to be right. It can't be wrong. Let's go on to number 6. We can divide both sides of this by 6 because 6 goes into 18 so nicely. That's just a nice starting step. So we get y minus 5 is equal to 18 divided by 6 is 3. Let's add that 5 to both sides so we get the y by itself, and y is equal to 8. Let's check that real quick. 8 minus 5 is 3. 6 times 3 is 18. That checks, so this answer is right. It can't be wrong. And then number 7. Number 7, I've got x's on both sides. That's one of the things that makes this problem more difficult. So let's go ahead and solve that right now. Let's get all the x's on one side. So I'm going to subtract 2 x's away from both sides. That gives me no x's on the left, just that negative 5. And it gives me x minus 9 on the right. Let's go ahead and add the 9 to get it away from the x. Always doing the inverse operation, or doing the opposite of what we see. We see a minus 9, so let's add 9 to undo that. Negative 5 and positive 9 should make a positive 4, so x is 4. Let's check that. If I put a 4 on this side, I have 8 minus 5 is 3. If I put a 4 on this side, I have 12 minus 9 is also 3. That checks, so this answer is right, and it can't be wrong. There's numbers 5, 6, and 7. Okay, number 8, we're doing equations and problem solving. We're given 2 consecutive integers, and that their sum is negative 35. We need to do a couple of things here. We need to write an equation that models the situation, and we need to find the value of the 2 integers. So we need to find the 2 numbers. So let's see what we can do. Consecutive integers. Well, if one of them is x, the other one is just one more than that, so it would be x plus 1. So here's my 2 integers. I've got my first one x. I've got my second one x plus 1. Those are consecutive. It says if I sum them, which means to add them up, they will equal negative 35. So there, I've done that first part. I've got an equation that models the situation. X and x plus 1, my 2 consecutive integers added together, that's a sum, is equal to negative 35. Now I just need to do the second part, which is find the 2 integers. So let's just solve this. If I take x plus 1, that's 2x plus 1 equals negative 35. If I subtract this 1 from both sides, trying to get that x by itself, 2x is equal to negative 36. Dividing by 2 gives me x equals negative 18. Well, if this number is negative 18, this number is negative 18 plus 1, which would be negative 17. So it looks like my answers are negative 17 and negative 18. Let's just check them. Are they consecutive integers? Yes, they are. If I add them together, do I get negative 35? Yes, I do. So this is my answer. It has to be right. It can't be wrong. That's number 8. Okay, number 9 is easily the most difficult problem on the exam here. So let's take a look at the number 9 and break it down. It says at 9 o'clock on a Saturday morning, 2 cyclists are heading in opposite directions. They pass each other on a path. The bicycle heading north is 4 kilometers an hour faster than the one heading south. It says at 10:30 they're 39 kilometers apart. The question is, what are the 2 bicyclists' rates? In other words, how fast are they going? Well, let's set up a little box here. This is clearly a rate times time equals distance problem. When I work a rate times time equals distance problem, I really like to put the information into one of these boxes. It just makes it so much easier for me to organize it and find an equation that I can use to solve this thing. So I know this rate times time equals distance, so I'll go ahead and label my column headings with rate, time, and distance. I know I've got a northbound cyclist and a southbound cyclist. That's a terrible looking in. Northbound and southbound. Let's fill in everything we can find. It says that the one going north is 4 kilometers an hour faster than the one going south. Well, they told me nothing about the southbound cyclist speed. They told me something about the northbound in comparison to the south. So since I know nothing about the southbound cyclist speed, I'm just going to let that equal x. That's what we do when we have an unknown. We put a variable in its place, and what's unknown right now is the southbound cyclist's rate. Now that I know that the southbound cyclist is going x kilometers an hour, all I have to do is make the northbound cyclist go 4 kilometers an hour faster than that, which would be x plus 4. Okay, that takes care of the rate column. I'm to the time column. It says they met at 9 o'clock, and then at 10:30 we have a distance where they are apart. Well, from 9 to 10:30, that's 1.5 hours. So I need to put 1.5 in here somehow. I can use 1.5. I can use 1 1/2, that mixed number. Or I'm going to choose to use 3/2 because I just think it's easier to calculate with it. If you want to use 1.5 and use your calculator more in the calculation, that's fine. I'm just choosing to use 3/2. And then I know that rate times time equals distance. Oh, let's pick this up first. They're 39 apart. That's a total distance between them. So if it's any totals that I get out of this information always goes on the bottom of my chart, my table, because northbound didn't do 39 by himself. Southbound didn't do 39 miles by himself either. So it's a total. They did this together. So that always goes on the bottom. Sometimes we look at a total time, and sometimes that's a more difficult problem. Sometimes we look at a total rate. But often we're looking at a total distance, at least in this level of math class. So that goes here. Rate times time equals distance. The southbound person has a rate of x and a time of 3/2. If I multiply those together, I should get that person's distance. So that southbound person went 3/2 x kilometers total out of the 39. The northbound, if I multiply theirs together, I get 3/2 times x plus 4. So they went a total of 3/2 times x plus 4 kilometers. It turns out that an equation usually falls right out of these tables. So I've got the distance that the northbound rider went plus the distance that the southbound rider went has to equal the total distance traveled. So there's my equation, and I can solve that to find what they asked for here, the two rates. So let's go ahead and solve. I don't want to distribute fractions, so what I'm going to do here is I'm going to try to shorten this up a bit by multiplying both sides by 2/3. Since I don't want to mess with fractions, I'm going to get rid of them as fast as I can. When I distribute here, I multiply 2/3 times 3/2. That's 1. That's awesome. So 1 times x plus 4 is just x plus 4. Plus, when I multiply 2/3 times this 3/2 on the distribution here, that's 1 again, 1 times x. Well, that's awesome. That's just plus x equals. Now I need to multiply 39 times, let's get this right. I multiplied the left side by 2/3. I better multiply the right side by the same thing, 2/3. 39 times 2/3. Well, let's see. 3 goes into 39. 13 times 2 is 26. So isn't that nice that even when I multiply the 39 times a fraction, I get a whole number? They've really picked nice numbers in this problem for us, so that works out nice. Welcome to high school mathematics, huh? The real world doesn't always work that smoothly. X plus x is 2x plus 4 is 26. Let's go ahead and subtract the 4 from both sides. We're about to the end of this thing now. 2x is equal to 22 and x is equal to 11. So my southbound cyclist was going 11 kilometers an hour. And my northbound cyclist is going 4 kilometers an hour faster, so 11 plus 4 would be 15 kilometers an hour. I'll leave the check for you to work. This does check, it does work. That's number 9. Okay, concept 4 here, we're solving inequalities. So really we're just doing what we would normally do with equations, except we have these inequality symbols. And really the only difference is just remembering when to flip those things over. If we remember when to flip those things over and we can solve an equation, we can do these. They're really not that big a deal. So let's just dive in here. I've got number 10, w plus 2 minus 2 times the quantity w minus 24 is greater than 0. So let's distribute this negative 2 right here. So negative 2 times w is negative 2w. Negative 2 times negative 24. Make sure you distribute all the way through. Is positive 48. Negative times a negative is a positive. That's still greater than 0. Let's combine some like terms. W and negative W, or negative 2W is negative 1W. 2 and 48 is 50. It's greater than 0. Let's take this up here. If I subtract W from, let's just recopy that. If I subtract W, or not W, if I subtract 50 from both sides, I get negative W is greater than negative 50. If I divide both sides by negative 1, here's the kicker. I just did the thing that forces me to flip that guy over. If I multiply or divide both sides by a negative number, doesn't matter what number I'm dividing, it's what I'm dividing by. If I divide by a negative number, I have to flip the sign over. So that sign gets flipped over in the next step. Negative divided by a negative is a positive. That's what we want. A negative divided by a negative is a positive. That's what we want. I've got W is less than 50. That's number 10. Let's go to number 11 here. Since 6 goes into 24 so nice, so let's just go ahead and divide both sides by 6. I've got K minus 11, then it's greater than 4. Let's add that 11, and we get K is greater than 15. That's nice to have a nice quick problem after that one that took us a little more work. And number 7. Well, 11 doesn't go into that side nicely, so we're going to distribute. So I've got 7 plus 18. 7 plus 18 is greater than or equal to, don't lose the symbol, the or equal part of that. Let's see, 11 times y is 11y, and 11 times 7 is 77. Let's go ahead and, this is 18y right here, let's keep that straight. Let's subtract 11 y's from both sides, get all the y's on one side. So that gives me 7 plus 7y is greater than or equal to 77. That's a lot of 7's right now. Let's subtract 7 from both sides. 7y is greater than or equal to 70. I think you can see where we're going here. Divide by 7, and y is greater than or equal to 10. And that's number 12. And then finally number 13. Let's take that up and over into here. Let's see, let's just copy it. 4y's minus 8 is less than or equal to 5y's plus 12. I'd like to get all the y's on one side. Again, when something is making a problem difficult, deal with it. Deal with it right away. So the thing that's making this problem difficult is y's on both sides. So let's deal with that. Let's subtract 4y from both sides. Let's get a pen that writes instead of a highlighter here. 4y from both sides. That gives me negative 8 is less than or equal to 5y's minus 4y's is 1y plus 12. Now let's subtract 12 away. Get that y by itself. Negative 20 is less than or equal to y. You can leave your answer like this, but I'm going to turn mine around and say y is greater than or equal to negative 20. Remember, this says y is bigger. This still says y is bigger. Make sure they say the same thing if you take that extra step to turn it around. And that's numbers 10, 11, 12, and 13. Right, we're down to our last two problems on the exam. Absolute value. Absolute value of these little guys right here. These little symbols. These straight up and down pipe things. Those are absolute values. Not the 5, not the 2, just the absolute values. These have a little trick or a little thing we have to watch out for when we're dealing with these. So let's solve, just like there wasn't an absolute value there, just like that said 5x minus 10 equals 25. Let's just solve away. So we would add 10 to both sides and get 5, absolute value of n equals 35. And then we would divide by 5 and get absolute value of n equals 7. At this point, we need to try to find all the numbers that we could put in for that n right there and get 7 to come out the other side. Well, there happens to be 2. If I put in a positive 7, absolute value of 7 is 7, that would work. But if I put in a negative 7, it would also work. The absolute value of negative 7 is 7. So these absolute value problems, they have two answers. And we have to make sure we get them both. And in this case, it's just a simple positive or negative 7 that would work. Number 15 is a little tougher. We're going to treat it like it's an equation, like these are just parentheses, because it is an equation, and those are grouping symbols. We can go ahead and divide, and we'll get absolute value of x plus 1/4 is equal to 4 divided by 2 is 2. Now I've got an absolute value. Remember up here when we split the absolute value, we basically said that the thing inside here could be 7 or the thing inside here could be negative 7? Well, we're doing the same exact thing down here. This thing right here could either be 2 or this thing could be negative 2. And that's actually two separate equations that I don't think we want to try to solve in our head. So let's split them out. That could be 2 or that could be negative 2. And let's just go ahead and solve away. If I subtract a quarter from 2, what do I get? 1 3/4. And if I subtract a quarter from -2, I get -2 1/4. So here's my two answers. X could be 1.75 or X could be -2.25. If we plug either of these in to the original equation, they will work, and I'll leave the check for you. That's numbers 14 and 15.